Det er sant.
Selv om Svebben burde jeg kunne veldig godt.
Men det er jo du faktisk har brukt det.
While Linux is the obviously more interesting bit of that course here, I'll still wrap up some of the thoughts about the object files and materials and so on. At checkpoint, how would you load that kind of file? What do we need in our in OpenGL or in our in C++, so we can submit something to OpenGL?
I mean, we need to store all its vertices and I guess the order the vertices are being drawn in.
Yeah.
Or we need to change the order depending on the normals.
Yeah. Depending on
vertex normals. No.
What defines the order a bit more? Those guys back?
Ah,
the faces, right?
Yeah.
So
yeah.
Cool. Other thoughts?
I guess I would systematically read line by line and then find the V's and the F's for the vertices to basically connect them properly.
Okay.
As well as the texture coordinates.
Mm-hmm.
Yeah.
Mm-hmm.
In that same run.
Okay. Yeah.
Do we really need the normals in OpenGL?
Well, if you want to define what's the which side the surface is facing, but you're right. They're optional anyway.
Yeah, yeah.
So it would determine those sides as well. But the more information you have, the more if you have it, you probably should keep it. I guess.
Sure. If you have a model that's listing the F's in the right order, then you don't need the normals. But if they
that's not part of a specification.
Yeah, but if they don't, then you kind of fuck up the lighting and stuff.
You kind of fuck up the lighting and stuff. Yes,
yeah,
that's roughly what you do.
Some triangles won't be rendered because they're rendered on the inside, and some might be
exactly.
Not.
Yes.
Yeah.
You're right. You're actually right there, because the listing of those ones, there is an implied order which is by convention counter clockwise, but again, it's a recommendation at best, I would say. There's no one enforcing it. In fact, you can't even enforce it because you can't read the intuitions of the modeler anyway, right? So I wouldn't rely on it. So I think it's fair bet having a proper specification here and have the associated normals. So, but reading this base structure is pretty much what you say, right? So it's collecting, basically parsing the entire object file, collecting all vertices, then the vertex. So that was the UV information, so vertex texture coordinates, the normals, and then the magic comes. That's basically the faces, right? So you kind of collect the indices and then access the previously extracted components like V, VT, and VN, and so on, and then basically tie them up into a final vertex specification that includes all those components. That's the idea. Yeah. All right. So let's try that. To some extent. So the first thing, that's some other. I hope that will run anyway, because I kind of. All right, so what we probably need first is some sort of dedicated function that allows us to actually, give us a model file as input and get some vertices and, okay, looks darker than I thought. Texture coordinates and normals as output, right? So that's probably the first, and we can just call it get model or something like that.
Could you maybe zoom in just a little bit?
Hang on. Sorry?
Could you zoom in just a little bit?
Yes, I should. You're right. Okay. I ask that every time, but Ah, there you go. Cool. So we need to get a model. Hopefully it works out. We have a some sort of input which happens to be a path to a file. I think I should have one. What else? Vectors. Yeah. Help me here. Sorry? What did I do?
Is it too much? It's too close.
Yeah, a little bit.
Ah, all right. There's a too much. Okay, that's cool.
But I mean, I would feel like an asshole complaining. The text is too small, then you zoom in. The text is too big.
Granted.
But it was better than having a tiny image.
Yeah, admittedly. Yeah, I have a bit of a. It's surprisingly how skewed your perspective here is from the front, because you really don't perceive it the same way. It's really, and since I'm freed from any sort of empathy, I need to rely. So UV coordinates, 2D coordinates, right? So so we need to have those ones as well. It's actually very not intuitive to type like that. Final UVs. We'll just make it brief, and then the last one being.
Excuse me.
Yeah, I'm listening while I'm typing.
This would be a good chance to define mesh struct with those three vectors.
Yeah. Let's. Do you want to do it now already? Or? Yeah, we could, but you're right. So I just want to show the bare bone functionality because we don't build the whole. Because then you need to link it.
No, you don't have to do the thing I was.
Yeah. But I see your point. So you could have a mesh construct or struct, and then you pass that one to your OpenGL functionality. That's right. Okay. Anyway, just the baseline thing. Norms. So let's see. Do I have anything here? Cool. Let's take that and. So I prepped some object loader thing here, I think that's right. So it should roughly give me something to fill out. And the key idea is then that we just need to read the what did I say? I need to look for that. So those are the final. That's the final output. We probably need to collect some intermediate output first. What can we do? Yeah, let's get the file first. So we probably need to access that thing. To get the file, and we do that by fopen. And we have the path, which is passed along. We only want to read. No need to do anything else. And we have file is null. That's the standard stuff. And we tell the user that things don't work out this way. Printf. Yeah. Be very explicit.
Should use null pointer. Yeah.
Cheers. So cool. And we probably give up. So cool. So, but the more interesting bit is obviously that we need to now start collecting the individual vertices, right? So, yeah, how do we do that best? I guess just by iterating over it. Infinite loop, not good. Don't do that. But you can also break out, so which we'll do anyway. Okay.
Sure, you'll get to
Can
that
I-
point.
Can I
Sure.
Suggest.
You read the entire file first
Okay.
into a standard string.
Oh.
Okay.
And then you close the file. No, you don't care about the file anymore, and then you do the operations on the string.
Oh. Okay. You think it's
Simpler.
It's not simple, but
You can use the string functions.
I just wanted to scan the file basically, going take the input stream of the file without reading it in first. But yeah, okay. Okay, it's alternative pathway. I agree. Anyway, as far as my simpler version here goes, so the idea is that what do we need to get? We need to get a yeah, kind of need to read the line that we want to, or the symbol that we want to be dealing with. And the idea was there the come on, don't kill me. Right. So cool. So we expect a given number of words, I guess. Sorry. What do we need first? We need to scan for. Hang on, let me check the. We need to use scanf, and I just want to use the specification of scanf. Scanf. We are looking for what types. The types would be string of characters. That's right. So I just assume that I consume obviously a bit of a hack here. Set of symbols. Result. We're scanning the file input for string initially. So that is this as string of characters. What else do we need? We need floats later on for the individual coordinates, and yeah, that should do. So while I'm doing that, Jonas can prepare the alternative variant. And then we can have a look later. So, all right. So yeah, good. If there's dramas, if it's equals EOF, then we breaking out. So meaning we get rid of our without drama this time. So we're just breaking out. Cool. And in other cases, we probably need to start actually reading the file header, and that's the iteration we want to get at. So it's iterating over each symbol, and then we can basically just find whether do a string comparison on the vertex. Is that roughly what you wanted to do, Jonas? Apart from the full reading the file first. He's gone. All right. Okay. And then the idea is to read all subsequent elements, basically scan the entire line and fscanf, which would be based on the current location. Hang on, want to get individual float values. So hang on, we had 3 floats for vertex specification. Yeah, okay, cool, that should work. Yeah, followed by line break. That was the end of it. And yes, we need to store that somewhere, right? So we use the natural format that's compatible to that can be consumed from OpenGL perspective, and just fill the individual coordinates based on this pattern matching. So basically what it does here is on the incoming stream, do a pattern matching for 3 floats and a line break, and then associate the individual float values with the coordinates that the reference that I provide here. So, or allocate them there rather. So, good. Z. And this is number 1. So the only thing we need to then do, all right, we need to have a bigger structure to actually keep track of all that drama. Did I specify anything yet? No, I didn't. So we need to have some standard vector GLM vec 3 and oh God. Yep, thanks. Do the same for no, and do the same for UVs and the same for norms. And this one needs to be at 2. Cool. And we just temp cotton temp, right? Yeah. TMP. Temp vertices and then pushback vertex. So let's see if we can copy that pattern to make life a bit faster. Okay. Yeah, it should kind of work. Copy paste generally is a bad idea, but textures have 2-dimensional components. Let's be consistent. Let's see if we can do a proper refactoring here. Is it rename into V? Oh no, it takes them all. That's not what I was aiming for. Okay. Possibly have a
It's called
what am I missing?
TMP-UV.
Sorry?
It's called TMP-UV.
Ah, thank you. Thank you. That's right. Cool. Cheers. And the last one, which would be the normals, before it finally gets interesting. So and I missed, thank you.
Oh.
Ah, yeah, whatever. So Q, so and this one we get it right this time. Yeah, quite straightforward. Okay, so now the last bit is the yeah, the more interesting one. So again, what was the pattern there? Let's look at an example. cube will do. So pattern here was face, and then individual components separated by slashes. Yeah, we can do that, I guess. All right. Else, we want to make an else here. All right. Now we look for the symbol and look for an F. And if that matches, then okay, F scan F file, and now we need to get the pattern right. So most usable, yeah, decimal. It's probably the type we're dealing with. So we have maximum 3. So in this case, we are kind of harsh in terms of our assumed structure. So it's always the same. Cool. So now we need to store that stuff. So we have up to 9 decimals here right now. Yeah. Okay. So we probably need to have vectors. So they are just integers. So we just use those ones and create a word index array, and then one for the UV index 3, and the other one was the normal index, so 3. Yeah, that should do. Okay, so now we need to basically just map those individually, which is kind of painful but necessary. So word index 0. Followed by UV index. So VIDX. All right. And last one being NNIDX 0 to 3. So okay. Hang on. Let's fscan. I believe returns the number of matched characters. I think matched elements. Return on success. Number of items listed. The argument list successfully was successfully filled. Okay, cool. So we can do that check as well. Success. Okay. Colon. If so, we're matching 9 elements. It's not 9, then we are then we have trouble again. So. Wrong format. Face. Specification. And then, yeah, we exit out. In this case, we exit out. And return. Did we return anything? Hang on. Boolean. Cool. All right. So the last bit is basically just the, well, that's not just, that's the interesting bit. It's actually doing the right mapping, right? So we had the so we have the temporary ones which we store here. Final vertices. So, who is done already? No. I would have hoped so. Then I could stop. So, right. So we do that then for all the individual. What did I do wrong? Fine. No. That was more. I didn't mean that. Hang on. I'm just arguing. It's. He's talking to Jonas, but also surprisingly headbending to do that here. So what am I doing wrong here? Push back. I want to get the vertex index 1. First element, put it into the indices.
Vertex index.
What am I wrong?
It's isn't in that. No.
Yeah. We didn't specify the final vertex. I'll get there. So, right, you're right. I didn't. Thanks. Sorry for that. It's all in the mind, isn't it? So unsigned.
Sure.
And, yeah, okay. Yeah, final word index will probably do. UV index, and the last one is final norm index. Cool. So, push back. Word index 1, 2, 3, and so on. So we just pipette stuff. And the other 3 ones.
se alle diskene til Windows og diskene på Ubuntu. Eneste er at Windows har flest av låser, hvis du ikke skal være flest. Men
UV index, okay.
ja. Men det er nice hvis det liksom hvis det liksom har en fil liggende på Windows-desktop, så glemte jeg å legge på den til disken, så er det greit å faktisk kunne gå inn i Windows-partisjonen på Ubuntu og hente den. Den glemmer jeg ikke å gjøre.
So.
Det fikk et krav for inni pressen. Ja, men må du stemme for begge. Ja, så det er ikke inni pressen.
Done? Not yet? Okay. Cool. So now we did this one. They have the faces. So here's that would be the rest basically, which I don't know what to do with because we're probably not doing that right now. Yeah, Scott, I guess. F gets just consume whatever is in there.
Jeg tar en ekstra harddisk inn i PC-en min over CD-drive optical drive. Ja, who the fuck needs optical drives? Det er veldig kjøpt bare at jeg har bare kunne støtte bytte nummer. Altså, jeg har større nummer her. Hvis du bare ser til nummer, så er større nummer. Ja. Ja, deep pockets. Hell yeah. Folk som tar en litt speed. Ikke litt speed.
Index.
No.
Ja. Altså, det finnes ikke som det er en person.
Nei, det har vært stor nok begge holdning, så
du bare har et litt tegnemåten. Så har du more than 10 if it's a match.
Ja.
Enda bedre ut på hvilken åpning det er. Du bare trener en liten godt. Så trykker du på den sånn.
Nei, ikke det. Så er det godt drink. Og så inni deg, så tenker du det er ingen vil noe til. Hvis det er tau, så skal du slå opp ut det som ført opp til funktionsstyr.
helt klart.
Mye praktisk. Jeg fikk ikke lov å bruke det til å gå på damage.
Hvorfor ikke?
Fordi momentet ditt forsvinner ikke.
Så.
Ja, men
hva er det da?
så lenge du klarer å holde igjen.
Det er det på masse bansker på fingrene, men de er noen døde.
So just all right after that boilerplate stuff. So what is now? Hopefully we have at this stage collected all the individual references to the vertices and vertex texture coordinates and vertex normals from the face information, right? So they should all now be sitting in, if I got it right, here, right? So in fin vertex index, UV index, and norm index, and so on. And now the last bit is just basically to tie everything up to actually point back to the individual vertices that we have captured in our temp buffers before. All right, and since those are the real vectors again, we just come up with the individual elements again. So I call this temp. Temp, there you go. So lesson learned, better naming conventions here. I'm working on it. So so now I've extracted. So we're iterating over the phase specification there, and the idea is basically just to extract then now the vertex index. And save it into the corresponding vertex. Yeah, right. Relative important bit is to bear in mind that again the index, the reference from the faces to the index is starts with 1, right? So we need to subtract it by 0 to have the corresponding mapping in the temporary, the reference to the vertices in the vector here. So, right. So we do the same for UV index, and this would be UV, and we access, of course, the UV. What did I wrong? I do wrong. Of course, it's only 2 elements. And the last one is temp norms. Let's be a bit explicit. And this was the NN index. Cool. So, and this will then just be delivered as part of the output, which we called, or I called, final vertices, UVs, and norms. Final vertices, and we can just back the vertex which we have. Okay, so this would be UV. This would be the final UVs. This would be the final norms, and we push back normals. So, normals. Yeah, cool. So, and then the last thing we need to do is to, if we haven't done that yet, close the file. And I think that should be it, roughly. So did I forget anything else? So we have reference to the final output. We first allocate vectors and basically iterate over the file based on the leading symbol. Then we store the corresponding elements based on pattern matching. So it's 3 for vertices, X, Y, Z, that makes sense. 2 for UVs, X and Y, they're pushed into the right temporary vector, and then we are matching on Vn, which is the vertex normals, which is a vec 3 again. Pattern matching looks okay. And then we have this phase specification, and we need to extract all the individual indices, again 1-based indices for those components, and store them in the in some data structure pointing to the final indices. So we did all this, references look okay, and then we use those the indices to actually access the temporary vectors we allocated earlier and just extract the elements based on that from temporary vert normals. And this gives us then the vertices that are associated with the index specified in the face. Again, we do the correction by -1, so because we have zero-based data structures, and then push it into the final vertices and UVs and knobs. Cool. Yeah, I think it should do. So we'll see. Let's see if it actually does. So to spare me the boilerplate, I stole some code from elsewhere, which is pretty much just waiting for this specification. Model code. See if I have cube file in the right directory. Yeah. Okay. And then just run this thing. Ah, that's interesting. Okay, I must have produced some issue somewhere. These normals. Vector subscript out of range. What did he do? F-scan, X, that's all good. What?
Index into the vector at some point.
Again, sorry, please. But just repeat, I didn't get it.
If you are using the index in the vector at some point.
You're also missing a UV index. Further up. Slightly further up.
What am I missing?
You're missing there. You're missing UV index 2.
Ah, tack. Yeah, that's the one. Thank you. When I found that.
Still need normal
Yep,
index. Or
that's
0.
right. Too much copy paste. Sorry for that.
Maybe, yeah.
That's why I have you. You have a bird's eye perspective. So cool. That should probably.
Might be.
Are there 3 UV indexes?
Definitely.
What did I get wrong?
Are there 3 UV indexes?
Yes, it's for each component, right? So we have to.
Yeah, I get it.
3 different points. So there's
But do you
there's only 2 components in the UV indexes, but there's 3
Yeah.
UV indexes.
That's right.
There's just 3 that say this.
Still giving me trouble. I need to. Probably did some other copy paste error.
Oh.
Seems to be my.
Well, writing that much code before running it, it's doomed to have a lot of bugs.
Yeah, that's right.
But it will be hard to run it when you don't
I
have
admit.
anything in it.
Yeah, but yeah, it's hard to. Yeah, that's right. The intermediate. I probably should have done it a bit more cautiously.
Well, it would be hard to actually see something. So
Could print a bit more though. So vertex
Some
one.
breakpoints. Breakpoints are also decent
Hmm.
idea.
I mean, you're in Visual Studio, use it.
True.
Yeah. Well, I think since it's 12:05, we'll probably stop there and continue simply next session, and then we debug that thing to. Or if I figure it out until then anyway. But and we do that, and by then Jonas will have the ultimate solution anyway. So
The pressure, man, the pressure.
no pressure.